Okay, Bismillah Rahman Rahim. Let's get started. So today we will be talking about static systems, dynamic systems, and difference equation. Okay, so first, what is static system? Okay, so static system is a system that doesn't change over time. The value of variables in the static system is constant. For example, let x is equal to 5. So in a static system, the value of this variable will always be 5. Okay. For example, the x-axis shows time and the y-axis shows the value of x. So the value of variable x at time instant, let's say this is 1. So this is 5. At time instant 2, it is again 5. At time instant 3, at time 4, at time 5, at time 6, and so on. This will always be 5. So this is a continuous system and in discrete system. So this is one time instance, second, next time, next, but always the value of x is 5. So this is static system. uh, and in this system, the value for variable will always be same at different time instances. It means that the time will have no effect on the value of a variable. Okay, now what is dynamic system? So in dynamic system, that is a system which changes over time. When we model a system, we usually idealize the system in terms of its static variables. Okay, so variables are quantity that represent the system itself. You already know this. For example, a moving body may represent by static variables of velocity and position over time. In model of population dynamics, the system state variable may be the number of population that migrate, born and dead, and the existing population. Okay, let we have xt is equal to 5t. Now, what does this mean? This is an example of a simple dynamic system. The system is depending on the value of t. xt is equal to 5t. Okay, so this is the uh, we will have some explanation later on, but in this system, this is actually not exact t. This is usually xt plus 1 r. uh, at this position it will be one time instance, and at the other side of the equation it will be another time instance. For example, at time, let's say t1. Okay, or we can say that the value of variable x at time 2 is equal to 5 times the value of the previous time instance. Okay, we will explain this probably in the next slide, or this explanation is coming. Okay, now uh, let's talk about this system. This is the continuation of the previous slide. Xt is equal to uh, 5t. Again, as I said, this should be a different time instance than this one. The system is depending on the value of time. Okay, now for example, this shows time and this shows the value of variable x. At time t1, the value of variable x is this one. At time t2, it is the value of x is this one. At time uh, this, the value is this one. Okay, so this is a continuous system, and discrete system, this is one time instance, the value of x is this one. This is another time instance, the value is this one. This is another time instance, and the value is this one. So in dynamic system, the value of variable x depends on the value of time t. Okay, so this is comparison. This is a clear. Uh, Now, this is the difference equation, and as I earlier said that how it depends on time t. This slide is a bit important, so you have to give proper attention. Difference equation is an equation involving differences are as we said that we discuss about dynamic systems. So different equations and dynamic systems have a lot of similarities. Difference equation is a sequence of number that is generated recursively using a rule to relate each number in the sequence to previous numbers in the sequences. Okay, so you can connect these with the time instance. Now, for example, we have this sequence 1 1 2 3 5 8 12 21. Okay, so if you notice, we call this Fibonacci sequence, and how it is generated. uh, every number is generated from the addition of the previous two numbers. For example, this 2 is generated from the addition of this number and this number. This 3 is generated from the addition of this one and this one. This 5 is generated from the addition of this one and this one. This 8 is generated from the addition of this one and this one. This 12 is generated from the addition of this one and these values. So now what does this mean? This means that the, let's say the value of x, if this is x, the value of this x is dependent on the value of x at previous two time instances. For example, this is time instance 1, or this is time 1, this is time 2, time 3, time 4, time 5, and time 6. So if we are interested to find the value of variable x at time 6, so we have to use the values of variable x at time 5 and at time 4. Okay, so now look at this equation. Y, the value of variable y at k plus 2, at position k plus 2, or at time k plus 2. You can also replace this k by t. At time t plus 2 is equal to the value of y at time 1 plus the value of y at at time fk is equal to 1. Then the value of y at time k plus 1 plus k. So if this is, fk is equal to 1, so 1, and this will become 2, and then this will become 3 if we take k is equal to 3. So this means that the value at time 3 is equal to the value at time 2 plus the value at time 1. This is in the case of Fibonacci series. But you can also relate it with the dynamic systems, because we see that here the value of the current variable is dependent on the value of the previous values of the variable. Okay, so this is the difference equation. And difference equation, the value, again, the difference equation is equation involving differences. Difference equation is a sequence of number that is generated recursively using a rule to relate each number in the sequence to previous number in the sequences. And this is exactly what we defined as dynamic systems. Okay, so this is difference equation. It is further explanation that this value is generated from the summation of this one and this one. This value is generated from the summation of this one and this one. Okay, now the order of a dynamic system or difference equation is the difference between the largest and the smallest arguments k appearing in it. Okay, so for example, here yk plus 1 is equal to ak plus yk plus bk has order 1. So why this is order 1? So we have different arguments like k plus 1, k, k, k. So here we see that we have two different arguments. One is equal to k and one is k plus 1. And the difference between k plus 1 and k is equal to 1. So the order is 1. Now here, one argument is k minus 3, one argument is k minus 4. So the difference between k minus 4 and k minus 3 is 1. So the order is 1. Now, the here in this example, the arguments are k plus 3, k plus 1, and k minus 1. So the highest difference is k plus 3 and k minus 1. So the difference here is 4. How it is 4? So k plus 3. So three values are these, and then k minus 1. So it means that it goes uh, before 0. Okay, so like the difference between 3 and minus 1 is actually 4. So the order is 4. Similarly, in this case, 1 we have k plus 3 and k minus 2 and k minus 1. So the highest difference is the difference between k plus 3 and k minus 2, or the difference between 3 and minus 2 is 5. So the order is 5. Okay, so now what you have to do, I give you an exam, an assignment, and you have to do that assignment in your Google Classroom. And the assignment is you have to explore the different applications of difference equation or dynamic systems, and you can submit your assignment there. Okay, so thank you.